Welcome, everyone. Thanks so much for being here. My name is Chris King, and I'm a Senior AI Specialist Solution Architect here at AWS. And I've been a part of launching a number of our AI services, particularly for businesses, looking at first Amazon Personalize and Forecast, and more recently, Amazon Lookout for Metrics. Today, I'm really excited to be discussing how to apply machine learning to core business metrics. And by the end of this session, hopefully you'll feel that we've demystified what AI and machine learning is like here at AWS. And you'll know how to apply a few AI services to your business to more effectively manage core operations. So hopefully that'll save you both time while enabling you to be a lot more responsive to your customers and kind of the changing environment of your business. But I'd like to start with kind of some expectation setting and level setting, really looking to see if this sounds pretty familiar, that, you've really invested quite substantially in collecting a ton of data to really improve your overall analytics perspective. And you've created this. You might have data lakes. You have a number of things collecting, large-scale data warehouses, and all these tools together are functioning and they're collecting, but you're struggling to get actionable insights or really to understand the relevance of certain bits of information. And maybe you have more visibility into your actual business and operations, but you also struggle with the data operational flow for how to run these tools at scale. Or maybe too many tools or reporting dashboards, kind of this constant barrage of alerts for your end users that can generate a ton of alert fatigue. Or perhaps more basically, that your analysis is based on just purely historical data or maybe a few heuristics. And you're really challenging to take that forward and actually start predicting the future or understanding an event in real time. So is an event expected, or is it truly an anomaly? And in this presentation, we want to cover both Amazon Forecast for time series forecasting. We'll get into that more in a minute. And Amazon Lookout for Metrics, a service that focuses on anomaly detection. But before we dive into the specific services, it's kind of important to understand contextually where we're coming from. So at Amazon, we've been doing this with machine learning in various forms for 20 plus years. We're running one of the world's largest e-commerce businesses. And every single day, we're shipping millions of products over the .com portfolio to over 180 plus countries, monitoring billions of ad impressions. And we've been building systems at scale for both our .com business and AWS as a whole for a number of years. And this really gives us a perspective into what it takes to run machine learning at scale. And we've actually been able to take that and build tools that work for businesses at our scale, as well as AI services like the ones we're mentioning here that can go all the way from that scale to a much more maybe small boutique style business. So just because we're talking about large scale data volumes here, I don't want you to get the impression that those are required to make use of machine learning for your business. And we've learned a couple of things, mainly that customer data is quite unique, that actually generating these actionable results is really critical. And that uniqueness of data and the actionable results are kind of inexplicably twined. You can't really separate one from the other. The type of information you have about your business means that we can't give you a model that we've built for Amazon.com and it be relevant. We really want to understand what's unique to your data and build something that is tailored to those specific metrics in your data. And at the same time, when we then surface predictions, those results are much more likely to resonate with your business because they're tied at the scale you're running. But also, it's really important to be able to dynamically adapt to any kind of changing in intent. So just because an approach worked historically and we understand it and it's been quite performant, it can be totally ruined if there's a new emergent property in the market and you haven't contextualized it correctly. So we want to make sure that we build tools that allow you to specify these external events and be able to quickly adapt and leverage them going forward. But I think fundamentally, the thing that we've seen again and again in these services, and if you've seen any of our other presentations, you'll see this kind of mentioned in every one of them, is that building these accurate predictors requires significant machine learning expertise. And that expertise can be pretty difficult to come by, and especially difficult to build an entire practice around it to operationalize it, which gets us to a few barriers to machine learning and implementing it. We just talked about those ML experts that are needed. I'd say this is probably the most consistent barrier to adoption I've seen with customers. That especially as you want to invest in what makes your business unique, you may not have a core competency of supply chain forecasting in some way, or a recommendation engine may not be the thing that really differentiates your business. So it's unrealistic to kind of build a team of researchers around that topic and then to invest in it when there are commodity solutions available. So by having these commodity solutions available, it can address that lack of in-house requirement. Also, pretty consistently, a silo amount or silos of data. So it's really common to see a potential data lake in one area, a large-scale data warehouse in another, and then just a standard, random SQL database that contains a ton of customer information, like your CMS, for example. And these siloed data footprints make it incredibly difficult to bring information together and to generate, models of large insight on behalf of your business. And lastly is the need for expert guidance. So even if you understand the in-house expertise to build the model, even if you've constructed your data together so that now it's actually quite easy to siphon it all, generate predictions, and look at them, contextualizing that for your business can also be really, really complex and can be something that's not well understood. So just because a model makes a prediction, understanding where that relates to your business can be quite challenging. And so that's something with our AI services, we've worked really hard to simplify that and address these challenges to adopting machine learning. So with that, I'll get in again to the two services we're going to focus on today. The first is Amazon Forecast. This is a time series forecasting product. It is about understanding the historical behavior of, let's say, sales or marketing, or maybe even your total cloud infrastructure. How has it grown? How does it ebb and float over time? And then generating predictions that are actionable going forward. And also Amazon Lookout for Metrics. This is an anomaly detection service. The goal here is to capture real-time information about your business as well as historical data to understand the ebbs and flows that it has. And then as events are occurring, to quickly notify you when there's an anomalous event. And a service that's designed to kind of grow with your data over time and allow you to provide some feedback to the models just via the console. So again, we'll do a demo on this one, also deep dive at the very end. But to get started, I'll move on to Forecast and take a look at two customer case studies. To begin with Amazon Forecast, let's take a look at More Retail. More Retail is the largest supermarket and hypermarket in India. One of our flagship customers, and you see here from this really big headline, they were able to reduce waste by 30% and stocking costs by 3%. Those are really measurable, very impactful results from integrating the impact of machine learning on predictions into their daily decision-making ability and decision-making processes. And to dive into what that starts to look like, it's helpful to understand how Amazon Forecast is a little different when it's predicting things. Many tools, when predicting the values for next week, may say, 1,000 units in the future, 1,000 units next week. That's what we would consider a point prediction. Amazon Forecast behaves a little bit differently by giving you a probabilistic distribution. So instead of saying that 1,000 units next week, you can pick a quantile, which is a probabilistic amount. So let's say P70, and it'll give you a value for P70. So maybe it's 700 units next week at P70. And that means that 70% of the time, it's expected that the actual value would be below that 700 units. That's giving you kind of insight into what to expect. And now we start to kind of point that towards a supermarket operator. So how are they operating this market? And we start by clustering their items into a few different categories. So because they are a grocer, they have items that are produce that expire incredibly quickly. They can maybe sit on the shelf only for a day or so, and then they begin to turn bad. They have items that last a little bit longer in the produce section, so things that might be good for a few days or a week or so. And then they have goods that can be on the shelves for a few months, and they'll also have goods that can sit on the shelves for months up to a year that are quite stationary. Imagine paper towels, for example. And the decision-making and the purchasing around all of these needs to behave quite differently. So with Forecast, when we started working with More Retail, we really clustered all their items into these various categories. And the next thing we started to do was allow the deep learning frameworks in Forecast to not only build a model that understood a particular item, but also understood how that item was impacted by all the other items around it. So it's a holistic global model of their entire business that allows them to understand, that a quick expiring item is going to behave very differently, even a specific one, than an item that may sit on the shelves for quite some time. And so what we started to do here is take items, again, like let's say it expires really quickly, but the supply chain can refill it quite quickly. Well, stocking out's not the end of the world in that case. So what they would do is select a very low p-value, let's say p15, meaning that 15% of the time, the actual value will be below it. This is going to mean that they stock out quite rapidly. However, it's going to be good because there's no wasted produce on the shelves, and if the supply chain can keep up, this is a customer that can get new items in and just continue to provide value for their customers. However, items that can sit on the store for a bit longer or maybe have longer lead times, you may select a higher p-value, let's say a p-value of 60 or 70, and as they look at their inventory levels, they can adjust purchasing accordingly to make sure they have those staples that sit on the shelves quite reliably. And at the end of all this, what we see is the total results that they showcase. So here in this quote, you'll see them listing that they went from 27% to 76%, reducing waste by 30. That's a massive improvement for their produce category and something that their customers are engaging in continuously. Also, by reducing those over forecasting, it really helped them reduce their stockouts by 3% and improve gross margin. So this is giving their store managers, significantly more insight into what they need to be doing for their business and helping them understand the regular ebb and flows of their business. And that's just, for a particular customer, more retail. We've also had a really successful partnership with Anaplan. And Anaplan is a cloud-native enterprise SaaS company. They help customers with supply chain, sales, and HR. And in this case, they're actually generating a lot of their insights about their business and the metrics about their business inside Anaplan's SaaS. So as they're completing purchase orders or as they're updating their supply chain or financial planning, that's creating new data points. And what we've done is we've partnered with Anaplan to take the information out of Anaplan securely, build bespoke forecasting models for the customers on it, and then integrate those Amazon forecast findings back into Anaplan's SaaS solution in a product called Plan IQ. So that's helping their customers deliver forecasts incredibly quickly, leveraging Amazon Forecast machine learning, and giving them that, again, probabilistic decision-making that's quite a competitive advantage. So it's not just as a single customer that you can use this, there are partner solutions available as well. To take a step forward, it would be really helpful, I think, now to take a look at holistically, how does Amazon Forecast work to generate this highly accurate end-to-end forecasting? And you can see here that we start with pretty much the premise behind any statistical approach or machine learning, which is historical data. We want to take a look at what is the raw metric that you're looking to observe and predict. So that might be sales, it could be web traffic, it could be inventory. Really, it's a very simple data set of particular times, the particular entity you're interested in, and its overall value. And as that value shifts over time, that's what we're learning and that's what we're looking to predict. But we also support incorporating related data. And that has, there are two components to that. There's related time series data, which is just like the first, it's temporal. So there's some kind of item, there's some kind of timestamp, and there's some kind of related value, such as, is it a holiday or not? Is a promotion active or not? Is the promotion of a certain value? As well as data sets that are also built in. I mentioned holidays. We have a number of those that are built into the product already. But we also support ingesting weather data into a few countries as well. So what that's going to allow you to do is see the impact of weather on your actual forecast predictions. But the third category of information that's supported is item level metadata. So this is, again, where you have the timestamp and the item. In this case, it's just the item and other metadata columns that are independent of time. So this could be size, it could be color, it could be product family category. Really, it's anything that helps you understand your information and help cluster it. And you upload all this information into S3 and then subsequently into Forecast. Once Amazon Forecast has this information, the service can kick off and can look over all your data and generate a number of machine learning models to determine which approach is most effective in generating an accurate forecast for your data. Once that forecast or the model has been obtained, you can actually then visualize the results in the console to quickly see the behavior of your forecast and understand, is this reasonable? Are you really, is this consistent with what you were expecting? If not, it gives you a chance to really dive deep and understand, were your expectations off? Is there data that you'd like to add to the forecast to improve it? And once that's done, there are then two ways to consume the forecast. You can either export it as a CSV file and ingest this into any kind of data warehouse system you have or third-party application. Or you can, instead of taking the CSV exports, you can just natively communicate via an API and get the results and stream those into your third-party systems or applications. But the idea here is to take the information and quickly uplift it into third-party tooling or into your primary tooling so that your end users can make really informed decisions. The overall process is quite simple. I started to walk through it on the previous slide, but it's basically start by importing your data. Once the data is imported, we call it training a predictor. This can be done via AutoML, where all the algorithms are tried and evaluated to find the most performant result. Or if you've locked in on an approach that you're really happy with, you can select just that algorithm and train a model quite quickly. And then once that's done, there's generating the forecast. And generating the forecast is actually what's giving you your results. More importantly with this, Amazon Forecast allows you to have a very established data pipeline. So as your systems of record are creating new information, or we think back to that Anaplan example, as new information is available and it's being streamed into Amazon Forecast, the very next time you call to create a forecast, it's going to look at that most recent information. It's going to blend that in with the history it has, and then generate a forecast immediately reacting off the conditions from the data you just gave it. So it really simplifies the operational framework of running machine learning with just having to keep your data up to date and then the model continuing to churn out impactful results continually. The other thing on the right that's important to look at here, we've talked a lot about probabilistic forecasts, and this is the first chance you get to really visualize them. And so you can see here that the P90 is always higher than the others. They do have a similar ebb and flow, but the scales can be quite different. And by default, we surface a P10, P50, and P90 result. You can then specify any quantile that you'd like between 1 and 99, whatever suits your business best. And those really help optimize problems like staffing or hiring, and to understand the impact from shifting things like pricing and promotion, and also just to make sure that you are kind of acting accordingly with your expectations for the day. So if you know it's going to be, or you start to see that, let's say a day is really aggressive and things are going quite well, you may realize very early on that reacting to, let's say, a P90 forecast is far better than sticking with your maybe P50 value. So by giving this information to your stakeholders, it allows them to make better decisions. And I think that's the whole goal of injecting machine learning into these tools. Next, let's switch gears for a second and talk about Amazon Lookout for metrics. And just as before, we'd like to start with customer-focused examples of where they're getting value. And I'll start with Playrix. Playrix is the developer studio behind a number of free-to-play games. And very early on, they wanted to understand, looking at behavioral data from players. How are they engaged in their play times, their redemptions of certain rewards, and their overall quality of gameplay to make sure they were aware of any anomalies that could reduce customer satisfaction. And what they were able to do is, instead of taking an approach where all this data was aggregated, they were then looking at it periodically to identify when they saw, let's say, revenue drop by a substantial point, or they saw customers start to drop out of a game. They were able to proactively get anomalies on those very specific metrics. And when they got those anomalies, it had actionable insight of where that anomaly was likely to be, and then they could go look at changes in their other systems to determine what the cause of the anomaly was. And this has really reduced, as you see in the quote, the many hours of manual investigation needed to really hone in on the cause of an anomaly. So one, to even know that an anomaly occurred, but two, to get to the bottom of it and start mediating the issue behind the scenes. Similarly, there's this other firm, Digitata. They are a pricing broker between mobile network operators and customers purchasing mobile data in emerging markets in Southern Africa. And while here in the States, we may buy our data plans by, let's say, prepaid amounts of data, 2 gigs, and it lasts for an indefinite period of time, or you may have a monthly plan. These customers are purchasing data by the hour. So many gigabytes for the next available hour, or maybe 2 hours out. And Digitata acts as the pricing broker between those, balancing network performance and throughput and quality on one end with price on the other. So creating this really efficient marketplace for data in an emerging market. And within 2 weeks of actually deploying this solution on their mobile network operator networks, they were able to discover an issue that detected a 7.5% drop in customer revenue within 5 minutes. Basically, they had deployed a package. It negatively impacted a particular mobile network operator's customer purchasing behavior. They were quickly identified within 5 minutes. And more importantly, this is a continuous anomaly detection system. So as new data is coming in when they try fixes, they can quickly see if they've mediated this issue or not. So that led to them triaging it in 2 hours. where without Lookout for Metrics, this customer wouldn't have been aware of this issue for another, or Digitata wouldn't have been aware of the issue for a full 24 hours. And that would have led to a 7.5% drop in revenue for an entire day. So this is an actionable insight that's very impactful to the quality of business performance for their customers as well. And to dig into a little bit more detail, we can look at Amazon Lookout for Metrics end to end here. So before with Amazon Forecast, everything relied on data coming in from S3. What we see with Amazon Lookout for Metrics is a host of other data providers. We still start with S3. We also provide support for Redshift and Amazon CloudWatch. It's not listed here, but we're actually compatible with all RDS databases as well. But not just those systems, we also extend support to grabbing data from third-party services like Salesforce, Marketo, and Google Analytics. But once this data is ingested in, the services actually spins up a machine learning model, and it will continue to retrain behind the scenes and build improved models as it collects data. But it builds a model to detect anomalies on your data. And then as new data is coming in every 5 minutes, every 10 minutes, or every hour or day, it's actually looking at those data points and saying, is this anomalous from what we've seen before? And if so, it can then deliver alerts to your end users. We can do this over Amazon SNS or AWS Lambda. And then from those, you can create webhooks into things like Slack or ServiceNow or any third-party ticketing system you have. And at the end of this, you get to a human-in-the-loop feedback component, which is going to allow you to specify that this is an anomaly or it isn't. And that's going to improve the model that it's trained over time and really reduce false positives. So when you think about alert fatigue, this is the system we have in place to really provide fine-grained control and understanding of your behavior so that the anomalies don't overwhelm your users as time goes on. It's also helpful to start thinking about, what does an anomaly look like? We'll see more of this in the screen as we actually look at the console in a demo in just a moment. But here we can see on one side, we're looking at a particular amount of historical information, this blue line. And then from that, we see the start of an anomaly and the values continuing on. And this question of, is this anomaly relevant? So when the service surfaces an alert to you, you go into the console, you look at this information, and after your investigation to determine if it's a real anomaly or not, you can specify yes or no. That's creating that labeled data point just mentioned on the previous slide that improves the model. We also give you the ability to detect a severity score before issuing an alert. And that score can range from 1 to 100. And what that allows you to do here is to understand the overall impact of an anomaly or the size of it before you start alerting on every single anomaly that's detected. With customers, I regularly recommend that they start very low with a severity score to understand the behavior. And then as they understand the anomalies in their data set, they can set this threshold higher and higher so that they're just reacting to what they find important. But when you look at an anomaly, it's not just that historical time breakdown. You also see this image here on the right of the different domains in which it occurs. So think of these as categorical attributes. The data set that we're seeing here is an e-commerce data set where we can see that Android and iOS are both heavily impacted. Phones and tablets are both heavily impacted. But the majority country of impact is the US. But we can also see where other countries are impacted as well and mouse over for more information. You can then see product type and version information. And this is what initially kickstarts your discovery to understanding the cause of the anomaly. So this is the information based on the data that you provide that we can surface back to you to really kickstart that effort of your end analyst. And now to take a moment to see what the service looks like in action by configuring a real-time anomaly detection workload, and then also taking a moment to look at some results from previously of a backtesting variant we ran before. And the reason we have both modes is continuous, is for your real business as it's happening day in and day out so that you're alerted in real time. However, backtesting exists so you can understand the likely types of anomalies that will be caught by Lookout for Metrics based on your historical data. So we've already created that example. We can walk through it, but we'll set up a real-time detector first. So with an AWS account, anyone can get started with Amazon Lookout for Metrics today, or also Amazon Forecast, the service we've been talking about as well. To get started, you'll just enter the AWS console and you can search for Lookout for Metrics. And when you can click on that, and you'll be taken to this exact page, kind of splash screen for the service. You'll also need a data set, and we'll talk about that in just a moment. But the first thing that you'll want to do is get started by clicking Create a Detector. So we'll click Create Detector and give it a simple name. The description is optional. I'll skip it here for this purpose. And you'll also want to select an interval. In this case, our data arrives hourly. This is a simulated amount of e-commerce data. You can pick the interval that's right for your business. And it's about when the data arrives and how you'd like to aggregate the data and then detect anomalies on it. So let's say you get data every minute, but you'd like to detect the anomalies every 10 minutes. That would be this 10-minute interval here. But for our data, we'll be clicking 1 hour. Additionally, you can modify this with encryption settings. So if for compliance reasons, you need to keep the data encrypted with your own KMS token and fully support it that way, you can use KMS and click custom encryption here. However, the service by default will create a key for you and keep your data encrypted both at rest and in transit at all times. So the next step is to click create. You can see we now have this flow of information going from creating the detector, adding a data set, to activating, to alerts. Now, today, we probably will not be getting into the adding alerts. That requires the system to be fully up and operational. That takes several hours to train. We have quite a short webinar, but we are going to add a data set and activate it. So the next step is to add a data set. And we start by just clicking that icon and now giving it another sample name. So again, webinar, sample, data set. No description, again, totally optional. And here you have the option of specifying a time zone. My data happens to be UTC, so I'm going to leave it, but you could click here and select whatever time zone is relevant for your data. The next really important part is to think about the data source you're providing. So earlier we saw that we had Amazon S3, CloudWatch, Redshift, Aurora, all these RDS databases, as well as these third-party integrations. For our purposes, we're just going to use a set of data that we've exported into Amazon S3. So imagine you have a data warehouse that's constantly churning out exports into S3. That would be what this is simulating. So we'll click that. And we're given a couple options, backtest or continuous. We mentioned that we want to react to live data, so we're going to select continuous. And you'll notice a few things start to shift here. The first is this question that asks for a path to an object in your data set. So it's helpful to kind of look at what we're seeing here and start to reason about it. The first is that there's S3 path, a bucket, a live folder, and live could really probably mean anything, but it's a folder. And then we start to see a timestamp. So it looks like year, month, day, maybe hour, minute, and then finally a file behind the scenes. This concept of a root folder and then some form of time-based pathing is critical for lookout for metrics to function. This is done in a way so that the service can wake up periodically, look for new information, and reliably know where to find it. So to get started, what we're going to do is go grab an object in our data set, put it here, and the service will then try to reason about the pathing we've used. However, this is totally optional. If you know how to specify, you can click custom pattern and type this in manually. It uses a standard Java library for parsing time. But in our case, we're going to go back to the data set and grab an example. So we start by looking at this e-commerce folder we have in our bucket. We see we have a live as well as a backtest, so I'll click live. This means data running forward. Being a simulated data set, I can kind of pick any time in the future. I've already executed this, but imagine that this is data being generated by a production system. So the data would kind of exist constantly being updated as time progresses. So I'll click the September 16th, and I'll click another time here, and we see we finally get to a CSV file. So I'll click this file, and I will click to copy it, the URI of it, that's the address of this file, so we can get started with the service. And we'll come back, we will paste it. And now Lookout in the console is going to look at this and try to reason about the timestamps that we're using. And so when we click this, we see that it actually has detected year, month, day, which is exactly what we're using, as well as hour, minute. So perfect, it got it. We click this, and now we move on to the next question, which is the interval of the data source. So not just how frequently are we detecting, but how often are we updating the data? And in this case, it is hourly. So I'll select that. There is this option for an offset. So what this parameter allows you to do is to specify, imagine you have a real-time system on-prem or in some other cloud-based resource, and it could take 10 minutes at the end of an hour before things are up to date and those resources are exported. This offset allows you to specify that time in seconds before the service wakes up and checks. So this just gives you a way of making sure the data is available before anomaly detection starts. Given that this is a demo, we can ignore that. It's not necessary. And also we give you the ability to specify historical data. So this historical information is, think of it, your back export of data where the service can train and learn from it. I'd like to use that in this case to build a more accurate model more quickly. So we'll click Use Historical Data. And we'll go back to the bucket, clicking e-commerce again, then clicking Backtest, and this input.csv file. We will copy that as well and put it right here. Now, if you don't have this historical data, it's not the end of the world. Lookout is uniquely equipped for AI-based services to actually help you bootstrap with data. So the service will start by just recording observations until it has enough to build a really rudimentary model. And then as you're collecting more and more data over time, it's going to be able to use more advanced modeling approaches on your data. And all of that's handled totally behind the scenes with no real effort on you operating this at all. There are a few final questions about your data before it can parse it. So it is a CSV file in our case. We do have header rows. We use commas to separate things, double quotes to escape things, and the files aren't compressed. The last question is the permissions to go and get the data. I happen to have a different role I've created earlier, so I'm going to copy that. It's this Lookout for Metrics test role, and I will paste it here, entering the ARN of an existing one. And this is just permissions that allow Lookout for Metrics to go into S3 on my behalf, grab the content, and to take a look and read it and understand it first. So once we've done that, we'll hit Next, and it's going to attempt to validate the data. Once that's done, we can click OK, and we'll move on to the next step of engaging this information, which is how do we actually map the data from the input files into the service for machine learning. And while we can go through that in the wizard, it would first help to actually look at the information and better understand it. So with that, we'll take a look. We have a few fields. We have a platform field first, a marketplace field, a timestamp, views, and revenue. Now, the first thing that you'll see back here is measures. These are numerical attributes for our anomaly detection. So in that case, views and revenue are those attributes. And we're going to want to select those and then select an aggregation function. In this case, we'll start by collecting views, and we'll select revenue next, and we will choose to average them both. In our case, the data is provided hourly, so the aggregation function doesn't really matter. But if you are providing more data points in a given interval, this is how you could say add all these things up or take the average. The next thing is the dimensions. So these are the categorical labels that help make something unique. So if we go back again, we can see that PC web in the US is kind of unique for both views and revenue. Similarly, PC web also has UK and Germany and France and Spain and Italy and Japan. So these are very unique time streams that we want to detect against. If we did not select them as a domain, we would just add up all those entities earlier, like we said, via average. But in our case, now we'll add those labels. So next would be platform and marketplace. And in both of these cases, the order doesn't matter. We're going to be detecting the anomalies individually across each. So the order of operations you've selected here is totally fine. If you wanted to put revenue first and then views, and same for marketplace and platform. And the very last field is timestamp. And if you notice here, it's actually removing these categories as we're selecting. So I will select timestamp last. And to make things very easy, I've actually written the time data in this file according to this format. So I can just copy that format, paste it, and hit next. It's going to ask me to review this information. All looks good, and I will hit save and activate. You're going to get a notice that this will, again, to check against the free tier, and then it can potentially incur costs. The service is going to start looking at all the data, training a model, and then executing anomaly detection thereafter. So this is just giving us a heads up. We will now click activate, and the service will start building our model. This process usually takes around 4 to 5 hours, given the sample data set we've provided. With more data, it can take a little longer. Smaller data sets can be a little bit faster. But with that, we'll switch over to taking a look at our backtesting detector to see what anomalies look like in the service. So to look at our backtesting job, the first thing we'll do is click the detectors link here. When we've clicked this, we can see the real-time job that we have just kicked off, as well as a past detector that was created for backtesting. So with backtesting, we provide only the historical information. The service takes the oldest 70% of that information, builds a model off of it, takes the most recent 30%, and looks for anomalies within it. This is a really great way for you to evaluate the service's efficacy against your historical data and to understand the types of anomalies that are created. And in this case, we're actually using the exact same data set that we just used for real time to detect anomalies. So we'll start by clicking this specific detector. And with that, you can see that we created one, we added a data set, we activated, and the back testing is complete. So with that, we will now go to the anomalies link here, and we can start to see the anomalies that have been identified in this data set. So with a severity threshold of 70, we see 136 anomalies. We can drag this a bit lower. It will recalculate the total number of anomalies for us, and we can see now there are 153 of them. And if we scroll down, we can see which anomalies are here. So revenue versus views being impacted. So we'll click one at an 87% or an 87 severity score. And here we can see that within 100% of the French marketplace for PC web users, also at 100%, there was an anomaly that occurred. So that's a very substantial amount. That's why it's generating this really high severity score. You may see a high severity score as well for an anomaly that occurs over multiple domains. So we may have had France and the UK, or France, UK, and Germany, and we maybe have brought in other platforms, so PC and web and tablet, for example, in this data set. At the same time, the amount that the predicted value is different than the actual value, or the deviation, basically, can also impact the severity score as well. So in this case, we see this kind of normal, kind of just nice flowing curve, and then we see a rapid jump up, thus indicating the anomaly point, and then a follow-up value here. And if we'd like, we can also click to expand this. So we can see we had this really, really nice kind of normal trending value, and then a rapid jump up, which was far higher than anything else we had seen. And if this was a live detection, we would probably say this is a real anomaly, and we would click this yes, so that when the service retrains, it's actually going to improve the model, and we'll see more of these in the future, or we'll be more better attuned to them. And with that, I'll switch back to things in the PowerPoint to wrap up some next steps, as well as open things up for questions and answers. And to recap, it's really helpful to look at a few of the key benefits of using the AWS AI services for both Amazon Forecast and Amazon Lookout for Metrics. These services are incredibly impactful for allowing you to embed machine learning into your decision-making processes. And that can help improve how you track and monitor your core business metrics with increasingly improving accuracy. And that lets you leverage the experience of Amazon to enrich your own business. So you're not having to discover these lessons and how to improve accuracy over time. You're actually able to pick up with the experience we've built, use it into your product. And that fundamentally is going to lead to you saving time, reducing costs, and really improving the productivity, not just of your adoption of machine learning, but of your entire business as a whole. And to get started, we have a number of resources, really thorough documentation on both product pages. You can go and explore. We have links to videos, customer testimonials, GitHub guides to get started for more technical assets. And to get started with any of these, you simply first sign up for a free account, for an AWS account. And then within that console, you can get started building. Both services have a free tier that allow you to explore and understand the services to better see how they may fit your business. You can get started quite quickly, like we just mentioned with the demo and Lookout for Metrics. And with that, you'll be off to the races in no time. At this point, I'll switch to Q&A and take any questions from the audience. Thanks.